So, well, I think that a lot of people here is using Ganglia to monitor their servers. It's quite difficult when you have multiple jobs on the same server to monitor exactly what's happening on the server. You cannot know exactly why we have this peak on the load. And if you offer Ganglia to the users, they said, my node is overloaded and it should not be, or whatever. So obviously Ganglia is not the best way to monitor individual jobs, and I suppose that there is no other tool that we use for monitoring servers that can be used to offer a nice view on what's happening on the server. So the Slurm has a nice feature to work around that. That's the Slurm profiling that is based on HDF5 files. It will run every few seconds, will get the performance data of the processes in the shop, and will write it per MPI task and for all the nodes of your job in an HDF5 file. One per task, and you will get hundreds or thousands of files. The problem with the HDF5 files is that you cannot see the content until the job has finished, because they are binary files, so you have to wait until they are closed, then you have to merge them once the job has finished, and use some basic visualization tools to display the results. So obviously this is not the best approach, because you want to know during your job if it has some strange load or memory usage. And well, these are the pros and cons of this approach. The pros is that you don't need any central monitoring storage. The only thing you need is a shared file system with no root squash. That's a cons, obviously. If you use NFS or other file systems, usually you would prefer to have root squash enabled to prevent any user that may become root to do any damage on your files. Another of the pros is that it's very lightweight, because it uses the internal mechanism of Slurm of collection data, and storing the data. It's just a small amount of data that's written on every monitoring cycle, so it doesn't impact too much on the performance of the applications. The main cons is that if one node dies during the execution of your application, the HDF5 file will be corrupt. So you will not be able to analyze what happened in the processes running in that host. And as I said, no data can be retrieved until the job finishes. So what I did, I said, okay, the HDF5 file is a very nice solution, but it would be nicer if we can get the data nearly real time, and using the same base as the HDF5 file plugin, I wrote just a small variation of the plugin that instead of writing the data to a file, is sending the information to an InfluxDB server. It collects exactly the same information as the other profiling plugin. It has a small buffer to avoid overloading the network with small packages. So instead of sending a package every time you collect some data, you wait, aggregate up to 16K of data, and then you send everything together. And the information is sent to a central server using libcurl that's already integrated in Slurm with the Elasticsearch plugin. And this is more or less how it works. So the Slurm disk collect the information, send the information to the InfluxDB, and using Grafana we can display the data, and the users can have nice dashboards of their jobs, the individual jobs. So what's Influx? This is from the InfluxDB webpage. Influx is an open source database for time series data. And it's high availability, and it's quite high performant. With the latest version, the high availability is not there for free anymore. It used to be, but they have to earn some money, so they closed that part. InfluxDB offers a REST API to insert and query the data. And it's nicely integrated with Grafana, so you can query the data directly in Grafana and create nice dashboards and, well, see the data in real time. The information that the plugin can collect is the default metrics from the task monitoring system, as the CPU frequency, the CPU time, the CPU utilization, the pages of memory that the application has, the resident set size, and then the read and write megabytes to the file system. It's also possible to collect information for InfiniBand, luster, and energy through additional plugins. So the configuration of the plugin is extremely simple. Instead of using the two parameters used for the HDF5 plugin, there's one more for the database, but you just have to specify the host where you want to send the data, the database inside the InfluxDB where you want to store everything, and the default profiling level in order to collect the data. So you can define a default profiling of none, and nothing will be collected. You can define that you won't collect everything, only the task information, only the network or disk information, whatever. The default profiling is set to all, because this also allows us to collect information from the submit script, while with the HDF5 plugin you can only collect information from MPI applications run with the srun command. So now the SketMD guys also added the support of collecting information from the job script, but that was not there at the time of the development. So as I said, how we send the data to InfluxDB, we have a small buffer to aggregate the data, and Influx is using a very simple line protocol, so you write one metric per line, and it has this format. So you have the metric, you can apply some tags to the metric, the value, and the timestamp that's optional. So here we have an example, for instance, for the CPU time, for the job 24, step 1, and the MPI task that's running on this node with this value and this timestamp. The floating point data is sent with 2 decimal precision. That should be more than enough for this purpose of monitoring. Once we have all the data, we send it to the InfluxDB with the core libcurl functions, and it has just very simple syntax also, where you specify the database, the retention policy, that it's not yet configurable in the plugin, but it may be added in the future. And the precision is always set to seconds, because Slurm only can collect data every n seconds. You can specify the frequency you want to collect the data, but it cannot be milliseconds. So the precision will always be set to seconds. If there's some error with the Influx server, we don't want to start buffering too many data and affecting the performance of the application and the memory on these servers, so we just drop the data and keep going. And because of this, obviously, some data may be lost. But it's better to lose some data than to kill a job. And because of this simple line protocol, the data can also be sent to Logstash, and it's very easy to parse it with Logstash. So if you send it to Logstash, it can be later sent to anywhere. So what are the pros and cons of our solution? It's lightweight, obviously, because it's based on the same framework. All the information is available almost in real time. You only have the delay of buffering 16K of data. Usually with, it's around 30 seconds, the data that you buffer. There's no information stored locally, so if a node crashes, you will not lose any data because the data is not there. And the information on real time per job and task helps the user to understand how their applications are performing in real time. The cons is that we need a central database server, InfluxDB in this case, where you have to send all the data. So if for some reason the server dies, you will start losing data. And this is the same example we had before. We didn't know exactly what happened here, if it was just one job that started another process or started consuming more CPU. And this is the view with Grafana of the CPU usage. And we can see here two individual jobs, but one started at this point and the other one started at this point. In this case, we are running two Limpa executions. So you can see exactly why you have this big in the CPU usage in the memory. And the same for the memory. This Limpa is running two small runs, so you can correlate all the memory increases in the host to the individual jobs. And this is more or less the view that you will get in Grafana. You can filter per job. That's how we have set it up. So the user can simply insert a job ID and he will be redirected to a Grafana dashboard with the data of his job and only his job. He doesn't care what else is running on the host. So for conclusions, it's very easy to set up. InfluxDB is a Go daemon. Obviously, everything is in Go today nowadays. You only require one config file in the config nodes for specifying where to send the data. The real-time monitoring enables faster reaction to issues. So if you see your application is not doing anything, you can kill the job. You don't have to wait until you reach the workload time. Also, better monitoring implies better understanding of the usage of the cluster. And you get monitoring information related to jobs and not only to the nodes. So you have more fine-grained monitoring information. All the code is available in GitHub, so you are free to try it and use it, and hopefully in the future it will be integrated with Slurm. I have not yet contacted the developers, but I will. And here you have some references for InfluxDB, Grafana, Slurm, obviously, and the Slurm provider interface for the HDF5. And that's it. Thank you for your attention.